Okay. So, case one. Distinct linear factors. So let's say you had to decompose a fraction or a rational expression that looked like this. We hit, yes, I did record. X squared plus X minus 6. So you first have to factor it. And you get X plus what? Plus 6X minus 1, right? So what you have to look at is the denominator. The bottom is distinct and linear, right?
Mhm.
So when that happens, when they're linear and different, you put A over the first one plus B over the second one. So integrating this is difficult. Integrating these two is no big deal. That's why we're going to do this. So this is case one. And then there's a technique for how to find A and B, which we'll do later. Let me just go over the cases because the setup is an important part. So that's how you set it up. You find there, basically you're saying there exists some A over the first one, plus some B over the second one. They exist, and you have to solve for them. Case two, when you have repeated linear factors. Let's say you had something like this, 2x minus 3 Okay, so the first thing you gotta do is factor. We'll factor an x out, and you're left with x squared minus 2x plus 1. And then that part factors into, let's go ahead and put it down here. X times, that's gonna be x minus 1 squared, right? This is a perfect square.
Mhm.
Now, you see how it has a 2 on it. So it's no longer distinct. X and this one is distinct, but this one is not distinct anymore. It's a repeated type. So what you do is you do A over the X, because that's just a linear factor. And then you go and you start with the highest power and you count all the way down to 1. If it was a 3, then I'd have 3 terms. You see what I mean? That's the setup for repeated type. So this is a combination of repeated with distinct. So A over the first one, B, C. Does that make sense?
Yes.
Okay, so that's how you do case.
Can I repeat the square on the B, under the B and the C? Why is it just one square and the second one is not?
Yeah, so that's how the rule is, right? If it's a 2,
Oh, okay.
you go 2, 1. If it was a 3, you'd have 3, 2, 1.
I got you.
That's how it's gonna be. You just keep adding a letter, A, B, C, D, whatever. Okay, so that's your case 3. Case 2, sorry. Case 3. Distinct quadratic factors. So this is the one you can't factor them. So something like this. So let's say the first one is just a linear term, but then you have this weird term. So this one doesn't factor. So you still just do the A over the first one. But this one, if you cannot factor it, you have to do bx plus c over the next one. Okay, does that make sense? So if you can't factor, this is what you do. Case 4. Repeated factors that don't factor is called repeated. Sorry, I forgot to spell for a second. Quadratic factors. So basically, it's going to be a combination of 3 and 2. Okay, so if you have 2x squared plus x plus 8 x squared plus 4 squared. So notice how this cannot be factored and there's 2 of them, right? So you're going to do ax plus b over x squared plus 4 squared plus cx. Well, actually, you know what? I'm sorry. You should be counting upward, not downward. Let me fix that for you. So it should be 1, and then the next one is 2. I got that backwards. So let's fix this one over here. It should be 1, 2. One, 2. You guys okay so far for these cases?
Yes.
Okay. Case 5 is something we'll do when it shows up, but this is the main idea. So I'll show you how to solve for A, B, C, D, all that crap in just a moment when we start doing the actual problems. Let me find the problems. Are you guys cool with the setup so far?
Yes.
Okay, 8 points. What section is this? 8.7? 0.5. Yeah, here it is. You guys cool on that page? There's no rush.
Can you return to the page?
Yeah,
real
yeah,
quick?
no worries.
All right. Okay, thank you.
All right, so 8.5, partial fractions. So step one, divide the fractions when improper. So that's the first thing you should do. If you see the degree on the top is bigger, then you're gonna have to do long division. And if it's not the case, factor the denominator is the second step you do. Right. And then once it's factored, use cases 1 through 4. So this is the order of the steps I want you to do. Check if it's improper. Put proper. Improper. That's funny. Okay, proper. There we go. All right, so this is why we do this. Example 1. The integral is equal to the integral of 1 over x minus 6, x plus 1. So you see how I need to separate this first, right? So we're going to integrate this eventually. So what I want you to first do is deal with the partial fraction. So remember how we said this will be equal to a over x minus 6 plus b over x plus 1. So this is an yeah, this starts time for a and b. So this is the procedure. So for step 1, for solving the a and b, multiply both sides by x minus 6 x plus 1. So both sides by this. You guys cool if I skip a minor algebra step, or I'm going to distribute this on both, right?
Okay.
So you see how these are gonna just cancel completely, right? So pretty much every time you do this, you're always gonna cancel the left side, leaving you with the numerator. Over here, let me go ahead and show it. I have space. X minus 6, x plus 1 times the a over x minus 6 plus x minus 6 times x plus 1 times the b. So these are gone. These are gone. So 1 is equal to, I'm going to put the a in front just because I want to, not because it matters. Put the b in front. Okay. So what we're going to do next is called equating the coefficients. So multiply those two. So then what you do is group the x's together and the constants together, and you factor it. So this is what I want you to think about. This is like the coefficient, right? I don't know why I was writing like be like that. So there is no X on the left-hand side. So what you do is say, well, I'm going to equate this coefficient to 0 because there's no X. There's like a 0x over here. And then you equate the constants to the constant, which is a 1. So you solve this system, right? As I think the easiest way, just use a calculator on your matrix with the matrix. Right. You guys comfortable with the matrix solver or no?
Mm.
I'm actually unfamiliar with that.
So what does everyone have a graphing calculator or no? I don't know what you guys have.
Yes,
I guess who doesn't have one? Guess you guys are all good then. So let me show you how to do it then. If you have 83 or 84, it should be the same thing. 89 might be slightly different. So all you got to do is hit second. And then X inverse. See how this is matrix above it?
mhm,
So this is the matrix menu. So when you go, see how there's matrix 1, 2, 3, 4, matrix A, B, C, D. So I'm gonna go make a matrix. I'm gonna edit A and create one. So I have a 2 rows and 3 columns, right? This is a 2 by 3 matrix. So then you just plug them in 1, 1, 0, 1, -6, 1. Then quit. Go back to the matrix menu. If I press enter, see, I can call it that way. But if I want to do operations on it, go back to the matrix menu and go to math. All these functions in here are for matrices. So go all the way to the bottom and choose RREF. And then go back to the matrix menu and press enter on the A to solve it. So there is my solution. They are not pretty answers, sadly. It's 1/7 and -1/7. So when you solve this, you can also do elimination, right? Substitution. But this is an easy one. You don't have to use matrix. You can just use either method. It doesn't matter to me. A is 1/7. B is -1/7. Okay. You guys remember how to do elimination or substitution?
mhm. I don't.
Let's see. Well, let's go to a different page so I could do it real quick. Scratch work. I recommend the matrix because if you have A, B, C, D, it can get really messy. But when you have just A and B, it doesn't matter. So we had what? A plus B equal to 0. And then we had, what was the other one? 6B, right?
Mhm,
Equal to 1. So if I multiply equation 1 by -1, I get -A minus B equal to 0, right? Now, if I add the equations together, this is 0. This is -7B. This is 1. So B is equal to -1/7.
oh, okay.
So if B is -1/7, A plus B is equal to 0. That means A has to be 1/7. So this is elimination. Substitution, you could say, well, let A equal -B, right? Solve for A, and then plug this in here. I'm sorry, I'll plug that in here, not there. Anyway, so So there's a lot of reviewing, I guess, if you guys have forgotten. Okay. All right, so we have A and B. So all that was just to prepare the integral, right? Let me give you some time. Oh, you guys cool with the other page? I kind of change it real quick.
No, that's fine.
Okay. Give me one moment.
Okay, write down this.
Okay. So 1/7 and -1/7. So don't forget those numbers. Remember the whole point of this, right? Let's go back to the beginning, was to integrate 1 over x minus 6, x plus 1. I'm just gonna go put the x over here to save space. So then we say I'm gonna integrate a over x minus 6 plus b over x plus 1 dx, which is equal to the integral. Now that we found these, right? We said a was 1/7, correct?
Yes.
We're gonna go ahead and separate these into different integrals. B is a -1/7. So now these are easy to integrate, right? These are just log ln types. You could do the substitution, but this is just a basic one. Let me show you. Pull out the 1/7. That's just dx over x minus 6 minus 1/7 minus dx over x plus 1. So I could say let u, this should be proper, equal that. Du is dx. Let w equal x plus 1. dw equals dx. So that would give me 1/7 integral of du over u minus 1/7 integral of dw over w. You see how it's going to be ln no matter what? So we don't really need to do the sub. Usually I just skip straight to here and say, you know what, that's 1/7 ln of x minus 6 minus 1/7 ln of x plus 1 plus c. So the partial fraction is just an algebra step to let you integrate it. It's easier. Does that make sense? So the partial fraction step happened in the last page. Oops. Okay, yeah, it's cool then.
Mhm.
All right, let's do another one. Okay, so this page is just the integral stuff. I mean, honestly, that's something you should already know how to do. The new stuff is right here. It's this partial fraction. Okay, so let's do it again. Example 2. The integral of 5x squared plus 20x plus 6 is x cubed plus 2x squared plus x dx. So the way you, so we're not going to integrate just yet. So what you end up doing is the partial fraction step first. So first thing you check, is the degree on the bottom bigger or is the top bigger?
The bottom.
Okay, so that means the next step is factor the bottom. So I see there's an x in common. You get x squared plus 2x plus 1, which is going to be x times x plus 1 squared, right? It's a perfect square.
Mhm.
So what rule are we going to use? Which case is it?
Yes. It is a case 4.
Case 2,
Yeah, this is case, let's see. Case 2, the repeated type, right? Yeah. So we're gonna have to count up to 2. So let me show my work. Let's rewrite this part so you can see better. All right, 1 second. All right. So this will be a over the first one plus b over x plus 1 plus c over x plus 1 squared. So we got to count up to 2. So there's the setup. So I'm going to multiply both sides by the LCD. That's how you cancel fractions. Remember how I said that this side will always cancel the bottom, so we don't have to worry about it. So I'm going to skip that step. Is that cool with you guys? Pretend I already multiplied this side just to save space. So now I'm going to multiply this right side. So when you distribute, sometimes the first one, like x's will cancel, leaving you with a times x plus 1 squared. Then the next one, like one of the x plus 1s will cancel, so you'll have plus b times x plus 1, right? Now the last one, the entire x plus 1s will cancel, leaving you with cx. I just multiply each one here. Is that, you see, I skipped the algebra steps there. And I multiplied that over here. Is that weird, or do you see it?
So you FOIL the entire x plus 1 squared to each one of the terms, right?
Right, and you end up with these three.
Okay.
And you do it to the left, which cancels the denominator. So you just end up with this. Okay. Okay, so then FOIL all this nonsense out. And then come gather all the terms that are the same. So a times x squared plus 2x plus 1 plus b times x squared plus x plus cx. And then distribute those letters. So ax squared plus 2ax plus a plus bx squared plus bx plus cx. Now gather everything that is the same to equate the coefficients. So ax squared plus bx squared. Now all the regular ax's, right?
Mhm.
And there's only one constant, the a. So you create an equation with the quadratics. So a plus b are the coefficients of the quadratics. Set it equal to the coefficient of the quadratic. Now do another equation for so 2a, b, and c for the x term, set it equal to the x term, 20.
Just a quick question. How do you arrive to the 5 again? A plus B?
So you're this is called equating the coefficients. So you equate the coefficients of a and b, the quadratic terms, right? A
Right.
plus b equal to the quadratic coefficient, 5.
Okay, good.
Then you do the same thing for the x's. You do 2a plus b plus c equated to the
The 20
the 20 coefficient of the x. And then you do the constant equated to the constant.
to 6. Okay.
Yeah, makes sense now. Thank you.
So once you create the system, you can use matrices, substitution, elimination, whatever the hell you want. Doesn't matter to me. To solve for ABC. Although this one gave me A right away, which is cool. If A is 6, what does B have to be? Right?
-1.
Yeah, exactly. -1. So if A and if you have A and B, then you can find C. Right? Because this would be 2 times 6, which is 12, minus 1 is 11. Subtract it over. C has to be 9. And if you don't see it, just plug in the numbers and solve for C. That's what I did. All right, so now we have the numbers, right? You guys cool so far? Any questions on these steps?
No.
All right, so the whole purpose, right? Was to get these numbers. So the integral of 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx is equal to the integral of 6 over, well, let me go ahead and factor this so it's more obvious. Because I had already done that, right? Doesn't matter, it's just preference. So 6 over a over x, so 6 over x dx plus the integral of a -1 over x plus 1 dx plus the integral of 9 over x plus 1 squared. Okay. Any questions on that setup? Because these integrals are no big deal, right? It was just you understand the purpose, right? You create an easier integral.
Mhm.
The answer will be, this is an easy one, that's just 6 ln x minus ln x plus 1. This one, the next two requires a sub. You'll end up with nine over x plus 1 plus c. Okay. Let's move on to another one. Let's do example 3. You guys cool on this page?
Hold on, give me 1 second.
Okay.
So when you put ln x,
The integral of 1 over x is ln x, right?
okay,
So the 6 is just whatever. So you integrate 1 over x, you get the ln x times 6. You integrate this guy, it's going to be ln of the argument. If you do a u sub, you'll see it's going to be du over u, which ends up becoming that anyway.
mhm,
So I don't
okay.
really, when from experience, whenever I see like a regular x, nothing on the x, like just so number 1, I just go ahead and go straight to here. But if there's like a 2x or a negative x, then I should just do the sub because things will change.
Okay,
But if you want to just do the sub every time to be safe, you're welcome to, but I don't.
okay,
And just remember, I would just say, you know what? If it's a regular x, you just jump to here. This is a
Okay.
use sub. You guys cool on this page? Or?
yes,
Okay. Okay. Excuse me. Okay. So this guy is going to be a repeated irreducible, right? You can't factor it. So that'll be equal to ax plus b over the first one plus cx plus d over the second one. Right? Now we multiply both sides by x squared plus 2, which will give us 8x cubed plus 13x equal to this one. Right?
mhm,
So they'll cancel one of those. So I'll be left with x squared plus 2 times ax plus b. Cancel all of those plus cx plus d. So now we multiply it all out and gather all the like terms like before. So this section was very algebra heavy. So that'll be ax cubed plus 2ax plus bx squared plus 2b plus cx plus d. So ax cubed plus bx squared plus 2ax plus cx plus 2b plus d. So here's the cube, the square, the x's, the constants.
Mhm.
So equate the cube, there's only one of them, let's equal to 8. Equate the quadratic, there's only one, there is no quadratic. Okay, that's cool. 2a for the x plus c is equal to 13. These two. These are all being grouped together. 2b plus d is equal to 0. There is no constant. So right away, there is no b, right? If b is 0 and d must then have to be 0, right?
Yes.
So we got a, we got b, we got d. So what is c? -3, right? Plug in a here. Solve for c, you get -3, right?
Oh, okay, okay. Mhm.
Okay, so we don't need a matrix there, but you could have made one if you wanted to. So now the integral of 8x cubed plus 13x over x squared plus 2 squared dx is equal to the integral of 8x over x squared plus 2 dx plus the integral of -3x plus 2 Does that make sense? What we're trying to do?
Yes.
Okay. This will just be an easy U sub. Well, both of them will be a U sub, actually. Okay, so let me show you, let's go over the partial fractions one more time. I'll let you integrate that on your own time. So this is another method for solving for A, B, and C. This is the first case I showed you, right? Remember how I said you multiply both sides, right? By
Mhm.
this. Now, when they cancel, you end up with this guy here, right? After
Yes.
you multiply every single term. When you get here, you could say, you know what, let x equal 2 to zero this part out. And then you get 2 plus 3, which is 5. So you end up here. And you solve for b right away. You see that? So instead of doing the equating the coefficients and creating systems, you could do this. This doesn't always work. This works when it's an easy, like we have, easy type of setup. Once you have b, you can do the same over here. So you know what? I'm going to let x equal -3, zero this part out. Then this becomes -5, and you solve for a. Right, so that's what they do over here as well. If you multiply everything out, you get to here. let x be 0, and you get rid of this part and this part. So then you solve for this. So a would be -3. Does that make sense? What they're doing? This is called the Heaviside method. So you equate the coefficients and create a system like I've been doing on paper. That works every single time. This Heaviside method works sometimes. So if you want to have an extra tool, you're welcome to go over it once you feel comfortable with this one. Okay. And if you look, if you Google other examples, you might see them doing one or the other. So I don't want you to get confused and wonder, well, why are they doing it this way? Or why not that other way? So the Heaviside method is super easy when it works. It becomes weird or difficult when it doesn't work. Okay. And I'm gonna throw this into the chat before I forget. Here is the partial fraction examples I was using. If you want to go through it, you're welcome to.
Okay, thank you.
All right. Let me see. I guess we'll stop here. So next time we will go over schedule here. So on Wednesday, we'll finish chapter 8 and review for the test. And I'll leave chapter 8 test open until the end of Halloween, until like Monday at midnight. Okay, November 1st.
Could we extend that like to the second or third? Because I actually had surgery and I have to go back like in a week and a half.
Yeah, that's fine, man. It's no big deal. We can do the 3rd, sure. But it's gonna be open starting, I guess, tonight all the way till the 3rd. It's no big deal.
All right, I appreciate it a lot.
And then the next week we're gonna hit chapter 9 kind of hard because let's see here. We're a little behind, not too much, just like a little bit. So next week we'll probably do more sections than usual. We'll probably stay and finish up 3 to 5 sections next week. Okay. Yeah, you guys have any questions about anything?
Do you think that you have time to do a sample for the exam? I kind of got doubt on that one. The one that has the springs. Let's see.
The spring, I think there's the only, let me look at it actually.
Number 14.
One moment. All right, it's number 14, you said?
Yes.
Okay, 1 second. So 14 says, let me copy it into the chat. So I'm reading it and thinking about it right now. It says a spring. The spring of a spring balance is 5 inches long when there is no weight on the balance. And it is 7.8 inches long with 4 pounds hung from the balance. How much work is done in stretching from 5 inches to 13.3 inches? Okay. Let's see. So first we gotta solve for the spring constant. Oops, out of paper. That's funny. Okay, let me think here. So we gotta use that first part, the 7.8 inches long thing. So spring 5 inches. So it looks like we're stretching it out. 7.8. All right, so I'm gonna need this equation, force equal to KD, which is Hooke's law. So I'm picturing that they're hanging it on this balance and it's stretching the spring downward. So 4 pounds would be the weight. Okay. So I'm thinking this is the force, right? The actual weight pushing down is equal to K times the distance. So the distance that it went from 5 to 7.8 is 1.8. So K K. That's pounds. K would equal 4 divided by 1.8, which is something. $2.22. Okay, so then they asked me how much work is done. So it'll be equation for work is integral from some A to B. What's the formula? I think it's fx, yeah. F of x dx. Okay. Where our f is the spring constant. So this would be the integral from starting at let's see.
It is from, it starts on 5, right? And goes to 7.8.
Yeah, so it'll be 5 inches. So we gotta change that to foot pounds. So I'm gonna put it at over 12. So 5 to 7.8 over 12. And use this as a function, so it'll be 2.22x dx, is what I'm thinking. So that will be, let's change those numbers, something prettier. 7.8 divided by 12, 0.65, 5 divided by 12, 0.42, 2.22x, which will be 2.22x squared over 2 from here to here. Let's see if I didn't forget anything. 0.65 squared over 2 minus 2.2242 squared over 2. I got 0.2442. I think I'm a little off here. Let me see. Sorry, wasn't on the page. Well, they had it in feet, so I didn't have to do that. Yeah, hold on a second, guys. I think I'm forgetting something. So it went to distance. They increased it. See, oh, here it is. Oh, shoot. 5 to 7 is 2.8, not 1.8. God damn it. Guys didn't correct me.
That's why I was about to ask you, where did you get the 1.8?
Who knows?
7.8. Oh, no, you are doing the, okay, 2.8, okay.
Yeah,
I see what you
the
do. I see
amount
what
that
you do.
is increased.
It's increasing, okay. Yeah, because in the exam it was compressing, it was not extending, it was compressing.
Yeah. On this one, it's stretching.
Yeah.
So,
the
but I
exam
think
was
it's the
the
same idea, because it's just the distance equal to the force that did it. So 4 divided by 2.8 is 1.4.
1.42.
Yeah. Okay. So then. Let me get a, hold on, let me get an eraser. It's easier for this one moment. So far we're on the right track. We just gotta get the bounds correct, because the bounds were not correct earlier, I don't think. So we're gonna integrate 1.43x dx. That for sure is right. We're extending the, how far are we extending it?
Uh, 13.3.
13.3, yeah. So the distance would be how much?
It would be 8.3.
Yeah, 8.3. So I think we should be integrating from 0 to 8.3 inches. Which will be 1.43x squared over 2 from 0 to 8.3. Which will be 1. 0.43 times 8.3 squared minus 0. What is that going to be?
$68.89.
So yeah, it's going to be
0.25.
49.25 or 7 inches, pound inches. There we go. Sorry, took me a second. Just forgot for a moment.
Mhm.
Yeah, so that's part A is the answer, 49 pound inches.
Okay,
So since they kept it in inches, we didn't have to do that divide by 12. If they said they wanted it in foot pounds, then you'd have to divide this by
yeah,
12.
they asked for inches. Inch pound, okay.
Yeah, so it's always going to be this distance, and then you use the information they gave you to find K.
Mm-hmm,
That's it.
okay. Well, I was thinking on this part of the integration, but I never thought about the formula for the force. I mean, to be honest, I not even know about that.
The Hooke's law?
How you call?
Hooke's law for springs?
Hooks?
Yeah, it's from physics 1. This one.
Okay,
This is the spring constant.
okay. Okay. All right, sir. Thank you very much.
All right, guys, and I'll see you Wednesday.
See you Wednesday. So you're gonna let us know if we're going back on the classroom or?
Yeah,
we're
I
gonna
think-
do
We'll probably Zoom this week because
Zoom?
they're
Okay.
having too many issues. So I'm gonna put it in the report. I didn't have time today, so I'm gonna do it tomorrow, and hopefully they'll fix that because it keeps freezing up on me.
Yeah, I remember. All right, sir. So we'll see you on Monday. I mean, Wednesday.
Yeah, see you later.
All right, guys. Good night.
Good night.